this example, we're asked to solve a cubic equation. The equation is 2x cubed plus x squared minus 7x minus 6 equals 0. Now, solving general cubic equations is difficult. It requires something called Cardano's formula. And that problem is too difficult for most exams. However, there are additional things that this problem asks us to do. The problem asks us to plot the cubic with a graphing calculator. This suggests that maybe our graphing calculator, the plot of our graphing calculator, will help us solve the equation in some way. So let us use our graphing device to plot 2x cubed plus x squared minus 7x minus 6. Now, please try to plot that on your graphing device right now. Please use the same graphic device you plan on taking with you to your exams. The resulting plot should look something like this. Alright, next. The graph appears to intersect the x-axis at 3 points. I don't know if you see where those points are, but here's one point. Here's another point. And here's a third point. So here's where the graph intersects the x-axis. These are the three solutions we're seeking to find. So the graph appears to intersect the x-axis where? Well, this number here looks like the number 2. This number here looks like the number -1. And this appears to be halfway between -1 and -2. But it's difficult to tell for sure. But one could guess with some certainty that the three intersections are at -1.5. So this point here, -1.5, -1, this point, and 2. This means that this left-hand side that we see here, if our guess for the numbers, for the three numbers, why am I saying the word guess? Well, because we eyeballed these numbers. We just looked at the graph, and it looks like the graph passes through the exact pixel that it should pass through, but maybe our eyes deceive us, right? So especially if you plot this with on a small calculator screen, it is very possible that due to the size of the screen, your eyes will deceive you, or that the scale of your calculator will not be fine enough. That may happen. So at the moment, it seems that we have guessed the solutions correctly, but our eyes may be deceiving us. Anyways, provided that our eyes are not deceiving us, the left-hand side should factor as well. It should factor as x minus x1 times x minus x2 times x minus x3, where x1, x2, and x3 are the three roots. This is x1, this is x2, and this is x3. Actually, the left-hand side should factor as the leading coefficient a0 times x minus x1 times x minus x2 times x minus x3. So the left-hand side should factor as 2 times x minus x1 times x minus x2 times x minus x3. So it seems that our eyes are not deceiving us. It seems that we have correctly eyeballed the factorization. But how can we be sure? Maybe our graphing device just is deceiving us, and maybe the graph, if we zoom, will not pass to the points minus 1.5, minus 1 and 2. Well, we do not need to rely on our eyes alone. What we can do is we can take that factorization and uncover the parentheses. If our guess were correct, when we uncover the parentheses, we should get the original polynomial 2x cubed plus x squared minus 7x minus 6. So in this way, we can I must admit that in the beginning we guessed this factorization, right? So this factorization wasn't guaranteed to be so, but we can verify that our guess is correct with absolute certainty. So there's no guesswork involved once we verify our answer. So yes, the graph did help us for some educated guess, but we're absolutely certain that if we uncover the parentheses and we get what we want to get, the original polynomial, we're guaranteed that this factorization is the correct one. So let's uncover the parentheses. First, minus with minus, so x minus minus 1.5 is x plus 1.5. X minus minus 1 is x plus 1, and just a reminder, in order to not have to deal with decimal numbers, I'm going to take the number 2 and I'm going to distribute it inside the parentheses. So I'm going to have 2 times x plus 1.5. That's what I'm having here. And I'm going to simplify that as 2x plus 2 times 1.5. So I'm going to simplify that as 2x plus 3. That is what I have written here. Okay, so what I have done is I have simplified this block to this block, so that I didn't. So I did that simplification, so I don't need to deal with decimals. I don't need to deal with the decimal 1.5. When I distributed the 2, the decimal 1.5 became the integer 3, which is much easier to work with. Alright, next, I'm going to uncover parentheses. What am I going to do? So I'm going to take those two parentheses, 2x plus 3 times x plus 1, and I'm going to distribute them. So 2x times x equals 2x squared. Next, the outer terms. 2x times 1 is 2x, and 3 times x, the inner terms, is 3x. So 2x plus 3x equals 5x. Next, 3 times 1 equals 3. So here I had 2 times 2, so 4 summands. Here I have written 3 summands. However, if you recall, when I uncovered the parentheses, I combined 2x plus 3x to 5x. So here I wrote 5x, which is obtained by taking 2x plus 3x. Alright, so our check works out. We expect 4 summands here, but we are having 3 because we combined two of these 4 summands into a single one. Alright, next I copy x minus 2. Alright, now let us distribute further. 2x squared plus 5x plus 3 times x equals 2x cubed plus 5x squared plus 3x. And 2 times 2x squared is 4x squared, 2 times 5x is 10x, and 2 times 3 is 6. and I have also copied the negative sign here. Please do not forget the parentheses. Okay. Next, I'm ready to combine. I copy 2x cubed here. Next, 5x squared minus 4x squared equals x squared. 3x minus, please pay attention, there is a minus in here, so 3x minus 10x is negative 7. And finally, I have minus 6. Please do not forget the minus. Okay. So let's take a look. 2x cubed plus x squared minus 7x minus 6 is exactly equal to the cubic that we wanted to factor. So our factorization, our eyeballing is correct. Okay. So we have not been deceived by our graphing device. We have indeed written a perfect factorization for our cubic. So our cubic 2x squared plus x squared minus 7x minus 6 factors is 2x plus 3 times x plus 1 times x minus 2. And that being equal to 0 corresponds to either x equal to negative 3/2. Just a reminder, negative 3/2 is minus 1.5. Or x equal to negative 1. Or x equal to 2. And that negative 3/2 in here is this one. Alright, our solution is complete. By the way, notice that the bulk of the work in this problem consisted in verifying that the original solutions that we eyeballed were correct. So if I were to blindly trust my graphing device, I could have immediately told you that 2x squared plus x squared minus 7x minus 6 factors like this, and I could have immediately told you that these are the 3 roots. In fact, I wouldn't have even needed to factor it. I could have immediately told you that minus 3/2, negative 1 and 2 are the roots without going through the factorization. However, the intermediate factorization was a tool for verifying that our graphing device has not deceived us, and that is quite important, right? We want to be sure that our solutions are